I'm going to go over that third problem that I gave you guys. 2018, number 5. This is the simple harmonic motion problem. My hands are all greasy. I got some paint on it. I think that's primer because I've been working on the Scout a lot. So they're going to look disgusting and beat up. Oh, look, there's some of that sweet mint green, like stuck right there. Okay, anyway. So block of mass M, horizontally frictionless surface like that, so no losses of energy due to that. Attached to a spring with spring constant K. So the block oscillates with period TP and TP in this day and age, and amplitude AP about the spring's equilibrium position, which is right there when the spring is not compressed or stretched out. A second block of twice the mass is then dropped from rest, so V initial equals 0 for that guy. Lands on block P at the instant it passes through the equilibrium position. Excuse me. Block Q immediately sticks. Okay, it sticks to it. Two things are colliding. It's a sticky collision. I know two things. One, momentum is conserved, and two, there's going to be large losses in kinetic energy of the moving block. That's by definition what an inelastic, I should say, collision is. Whenever they stick together, that's about as inelastic as a collision we can get. Figure out what the period of the combined blocks are compared to the uncombined blocks. Well, go to your reference sheet. Period for an oscillating block on a spring is given by 2 pi square root of the mass over spring constant. So it's going to be 2 pi square root of 2 plus 1 is 3m over k divided by 2 pi square root of only 1m over k. Everything cancels out except for the square root of 3. That's the answer. Next part. Wants to know about the amplitude of oscillation. Amplitude of oscillation is actually in the two formulas we have for springs. One is F equals Kx, and the other one is the potential energy. The potential energy stored in the spring is 1/2 Kx squared. It's actually the x. It's how far it goes this way, and then it swings back and goes that way. So that x is actually the amplitude of oscillation. So that's what we're talking about. That's what we're looking for. All right, so these guys are going to collide. Conservation of momentum says if you just took the momentum of the block before the collision, afterwards, all of a sudden, it tripled its mass. It's got to reduce its velocity by a factor of 3 so that when it cancels out, you get right back to what you have. That's what conservation is. So it's going to slow down. If it slows down, then here's where your loss of energy comes into play. Your 1/2 mv squared. Now it's slowed down by a factor of 3, which actually reduces its kinetic energy by a factor of 9 because that has to get squared. That was getting converted into the potential energy in the spring when the block went all the way to the most compressed part, because that's where it slows down, goes to 0, turns around, starts speeding back up the other way. So that was getting converted into 1/2 Kx squared. Can't change the K. It tripled its mass. So I was mistaken when I said that. It didn't get reduced by a factor of 9. It got reduced by a factor of 3. Because when you pull this fraction out, you'll get 3 over 9 times the original formula, 1/2 mv squared. Gets converted into 1/2 Kx squared. So you lost 1/3 of your kinetic energy. You're going to have 1/3 of your potential energy. That means you're going to compress a lot less. Now didn't ask for any calculations. Let's see if I hit everything, because this is a 6-pointer. All right, I said that. There's no point for that, though. All right, talked about conservation of momentum in the collision. I did do this even though it didn't ask for that, yet it's still worth a point. I don't know if I would have actually done that on the test. That's a tricky thing about this test. You don't exactly know everything they want you to do. All right, we said that the kinetic energy was decreased because it was a sticky collision. And I did say that the kinetic energy gets converted into potential energy in the spring. So I guess I got this point, got this point, got this one, got this one. I think I spoke about that to you, how it got converted into it. For a logical, relevant, and internally consistent argument that addresses the required argument, or, holy moly, don't know if I did this one.